All right.
Having a test.
We're having a test. No, we're not. All right, so r is equal to 1/2, which is less than 1. I apologize for those who are looking at the geometric series test, which is something you've actually already done. So quick overview for those of you that have no clue what's going on right now is that we're looking at geometric series. We're looking at the r value, and if that r is bigger than or equal to 1, we diverge, which means we go to infinity or negative infinity. If the absolute value of r is less than 1, then our terms will converge, and in this case, the converging terms will produce a series that converges. Great. What about B? So what I want to look at is I want to state that the absolute value of r is equal to, and what do I know about 3/2? So what we would state is that this diverges by the geometric series test. By the way, this part will take a lot of writing. It'll feel a lot more like stats for those who have experienced that class. Now, I do want to put one thing to the geometric series that's really important. The geometric series is the only series, you may want to put this is the only series where where you can be expected to find the sum of the series. So this is the only series where I'm expected to actually come up with a legitimate value for that. And that's something, again, in pre-cal you should have talked about, that S is equal to A over R, where A is our first term, and the R is our ratio we're looking at. So in part A, one of the things I could ask you is what does that actually add up to? So I would have to come up with an S. What was the first term of the series here? Turns out to be 3/2. So we do want to make sure, if in doubt, it's always good to write out the terms of your series, at least 3 or 4 just to get an idea. And it would be over 1 minus 1/2. This series actually equals 3. Any questions? Okay. Now let's look at the second test. Because there's that many situations. Huh? Absolutely. All right. Nth term test for divergence. The nth term test for divergence is going to be the smallest test that we're going to have to deal with. All right? And the nth term test for divergence says this. If we have some sort of series, what I can do is I can actually look at the sequence, A of n, and if I take the limit as n approaches infinity of the nth term of the sequence, and that equals anything but 0, my series diverges. I'll say that again. As long as the limit of my sequence as n goes to infinity is anything besides 0, my series diverges. Let's make sense of that real quick. What on earth, how does that work? What that says. I wonder how many new charts I have. A couple. What that says is, let's say I'm looking at a sequence, and I don't know, it's not going to look like a particularly good sequence because I'm going to probably mess this up. But let's say we start at 3. The next term turns out to be 2 1/2. The next term turns out to be 2 1/4. Next term comes out to be 2 1/8, 2 1/16, 2 1/32, 2 1/64. Hopefully you've all figured out what I'm trying to do. Okay. That sequence, if I take that sequence and if I were to expand that sequence to an infinite term, what would the limit of that sequence go to? It's approaching what? No, it is not. Hopefully you picked up that that sequence is approaching 2. Agreed? Now let's imagine we start adding these together. So now there's a plus sign between each one of these. Okay. As I keep adding these, we know that this is going to, each time I add a new term, I'm going to add slightly more than 2 to every single thing. But that slightly more than gets shorter, right? But eventually we're going to get such a small amount that essentially it's like adding 2. But the smallest value this goes to is, so if I keep adding 2 to the end of my series, this series is going to keep doing what? It's going to keep getting bigger, right? So while the sequence converges, the series will actually diverge. What? Now, makes sense. Pretty good, right? Now, here's the weird part, because we haven't gotten to the weird part about this. Please note the name of this particular series test. What is it called? Excellent. The nth term test for divergence. Notice in this box, the word convergence does not exist. Oh, here's where it gets fun, folks. Please do not mistake this test. This test does not say that if the nth term goes to 0, it converges. That does not exist. We will actually have some series where even though the nth term goes to 0, the series still diverges. We'll find out tomorrow. So, this test will only ever be proved for divergence. If you ever do an nth term test and you get 0 for your nth term, you're going to have to pick something else. You cannot just say, oh, it converges by the nth term test for divergence. So how does this work? What do we have to prove? To be able to use the nth term test for divergence, I need to look at my series, and I have to go, well, if I take the limit as n goes to infinity of this 2n plus 3 over 3n minus 5, what do I get? I get 2/3. What do I know about 2/3? It's definitely not 0. And since I have a limit that does not equal 0, we can say that this diverges by nth term. Now, I call it the nth term test. If you think you're going to make a mistake, you may want to put the nth term test for divergence. And you may put for like just div. You're allowed to abbreviate as long as the abbreviation makes sense. So for geometric series tests, please do not put GST, because then I'm going to think that you mean Greenwich Standard Time.
Really? It's Greenwich? Or
It's Greenwich. You're a Greenwich. Yeah, so a sequence can converge, but the series could diverge. Now, interesting thing, if the sequence diverges, then by nature the series must also diverge. But yes, we can have sequences that converge, but series that diverge. We have a lot of them. What about the next one? The limit, as n approaches infinity, of n factorial over 2n factorial plus 1. You should actually be able to tell me what you think that equals. It's 1/2. Bottom is always twice as large as the top. And we get 1/2, which is definitely not equal to 0. So we can say that this diverges by Letter C, we take the limit as n approaches infinity of 3 to the n minus 2 over 3 to the n. What do we get? One. And 1 is definitely not equal to, so we say diverges by nth term test for divergence. Okay, which may lead to some fun questions. For instance, what happens if the limit does go to 0? So for instance, if let's say we have the series n equals 1 to infinity, and I'm going to use the 2 that we had before, 3 over 2 to the n. Let's take a look at those two. Okay? In the second one, if I take the limit as n approaches infinity of 3 over 2 to the nth power, what do we get? We already know what that is, by the way. That's a geometric series that did what? This diverged, so we should get something that diverges. What is it? What do we get? What's the limit? 3 to the n grows a whole lot faster than 2 to the n. And what do I know about infinity? It's definitely not 0. Yes, you will put some stupid things on your paper, like infinity is definitely not 0. Really? So cool. It's cool. We good? So, interesting thing. I've already said that this diverges by geometric series because r was greater than 1. I could have also said that this diverges because the nth term test does not equal 0. So sometimes there's more than one test that will work. Sometimes there's not more than one test that will work. If I look at the next problem and I look at the limit as n approaches infinity of 3 over 2 to the n, what do we get? Now we have the nth term test that did absolutely nothing. The test did not give us useful information. We must choose a different test. At this point in time, we would then have to go, okay, well, what other test would this fit? This is a geometric. R is 1/2, which is less than 1. Ergo, converges by geometric series. So this is really, and realize, I am being very thorough with this. Yes, you are expected to tell me all of the conditions. You are supposed to show me all of the analysis. You have to show me the final conclusion. Okay, the last test I'm going to show you today, telescoping series. Ladies and gentlemen, telescoping series is never going to be tested on the AP test. I am not going to give you a homework question on this, but I do want you to see how the telescoping series test works because, well, in college you would have to see it. So I'm going to give you the quick glimpse on what the telescoping series is, and we'll move on. Let's say you have a series. It looks like this: 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. This is an example of something that telescopes. If I look at that, you should notice something about the terms. Second term cancels out with the third term. The fourth cancels with the fifth. The sixth cancels with the seventh. And eventually what happens is that we can see that those terms will eventually equal 0, right? So the limit goes to 0, and we can see some of these terms cancel out. This series, we would say, converges by telescoping series. In fact, in this particular series, we could say that this converges to what? 1, because the only number that will be left in the whole problem is 1. And that's all the telescoping series test is. So for instance, if I were looking at this problem, I would look at that and start writing out some of my terms. I would show 1/3 minus, what is it, 1/5? The second term would be 1/5 minus 1/7. The next term would be minus 1/9. And this would keep going. And you would notice that the 1/5 and the 1/5, the 1/7 and the 1/7, the 1/9 will cancel with the next one, which will be a 1/9. You can start seeing the pattern there. We would say that this series converges by telescoping series. Yes, there will be some telescoping series where it will not cancel as obviously as this. Sometimes it'll be like this term cancels with like the 5th term, and then this term cancels with the next term, and then they start canceling with a little bit of a gap. But what happens eventually is that all the terms will cancel. So for instance, you might get something like 1 minus 1/10 plus 1/2 minus . So as I can start seeing as this goes through, what's going to happen eventually? Eventually my numerator is going to equal 1/10, and that 1/10 will cancel out from right here. So I wind up with 1 plus 1/2 plus 1/3, and eventually what winds up happening is the only thing left is that we're going to get 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 plus 1/9. And at 1/10 they start canceling. This would be an example of a telescoping series that eventually funnels down to, because this 10 would eventually cancel everything else after that. Make sense? So yeah, it's not quite as obvious sometimes, but you can start seeing the pattern as you go through. Cool. Ladies and gentlemen, that's all I have for you today. You got an assignment? It is called the Worksheet on Infinite Series. The first 2 questions are calculator questions, where I ask you to find the first 5 partial sums. After that, the questions are all set up to find series using either the nth term test or the geometric series test, and deciding if that series converges or diverges. So good luck. We'll go from there.